If you have one equation in rectangular form, you can actually parametrize it a lot of different ways, actually infinitely many different ways. And in this video, I just want to kind of unpack like what changes in these different parametrizations. Does it just look different, or is the curve different, or just let's unpack some of those differences in different parametrizations for the same equation in rectangular form. So here we go. Let's assume that t is positive, and I have these three different parametrizations here. If x is t and y is root t, and if x is 2t, then y is root 2t. If x is t squared, y is t. These all look very different, but they're actually all three the same in the sense that they're the same, they would represent the same equation in rectangular form. They are all three different in parametric form, but they all represent the same equation in rectangular form. And you can see that if you complete this, if you eliminate the parameter. For instance, if x equals t and y equals root t, then take the x equal to t and plug the x in place of t into the other equation, you get y equals the square root of x. This is a parametrization for y equals the square root of x. If x equals 2t and y equals the square root of 2t, you eliminate the parameter, you also get y equals the square root of x. So these are two different parametrizations for the same equation in rectangular form. And even the last one's kind of strange. It doesn't even appear to have a square root. If x equals t squared and y equals t, then in this case you could take the y that's equal to t and substitute that y into the first equation, and you get x equals y squared as opposed to t squared. Then you take the square root of both sides and you get y equals, it sounds like it would be plus or minus the square root of x, but because of this restriction here that we have on t, this would leave us just with y equals the square root of x. So the same equation in rectangular form in all three, but three different parametrizations. So we see here that we can parametrize things differently, but now are there any other differences? Well, let me show you a graphical difference. First of all, the standard look of all three curves would be the same. You have a curve here, here, and here, and they're all y equals the square root of x. But there is a difference though. All right, let's trace this through various t values. If t is 0, then they all go through 0, 0, 0, 0, and 0, 0. But now if t is 1, look at what happens. The first parametric equations are at 1, 1, right? X is 1 and y is the square root of 1. The second set of parametric equations is that x equals 2, y equals root 2, which is farther along the curve. That's interesting. And the third one is at 1, 1, because 1 squared is x and 1 is y. And so you see, depending on the parametrizations, you might sketch through your curve faster or slower. At first glance, it looks like this curve is growing faster, moving through the curve faster than the other two, but let's keep looking. At t equals 2, this is at 2 root 2, this is at 4 comma 2, and this is at 4 comma 2. So that's interesting. This one has continued to move on, but this one's gaining ground. This one's picking up pace. I wonder why that is. Well, if you see, these are moving along in a linear fashion. Let's just look at the x's. The x's are increasing in a linear fashion, t and 2t. This is increasing in a quadratic fashion because this is t squared. So as time marches on, this first parametric equation will have an x coordinate of 1, 2, 3, 4, 5. The middle one will have x coordinates of 2, 4, 6, 8, 10. And the third parametric equation will have x coordinates of 1, 4, 9, 16, 25. So it's increasing on a faster order. And so you see you're sketching out the same curve, but along different paces. And lastly, for t equals 3, this one's hanging behind at 3 root 3. The second parametric equations are at 6 root 6. And by now, the third one is off our screen. It's at 9 comma 3. So you'll sketch through these curves faster or slower depending on your various parametrizations.